Scholars, are you sick of taking the limit as h approaches 0 of f of x plus h minus f of x all over h? Good. Right about now, you should be really sick of it. We're going to talk about the shortcuts, the rules for differentiation, so you don't have to go through that limit process every single time. So, what is derivative? Derivative is the slope of a function. So let's start with the first rule. If I ask you to take the derivative of a constant, well, imagine what the graph of a constant looks like. That was the first function in your function booklet. F of x equals a, so some number. When you graph it, you get a horizontal line. And what's the slope of a horizontal line? It's 0. So the derivative of any constant is the same as the slope of any constant function, which is 0. So the example on your paper, if I told you that f of x equaled 5, f of x is 5, and I ask you what f prime of x is, f prime of x is 0. The derivative of any constant is 0. All right, here's the next rule. What if we find the derivative using the long version? If I took the derivative of x squared, I think we've done that one enough times in class, the derivative is 2x. If I wanted to take the derivative of x cubed, I'd have to take x plus h and cube it. It takes 4 multiplications and then 6 multiplications. So, and I would get, you can see here everything cancels out except this 3x squared. There we go. So maybe you remember Pascal's triangle you could use it to help expand out polynomials. So if you want to raise a binomial to a bigger and bigger exponent, you could keep doing that. If we did it long enough, we would catch on to this pattern. Here's the derivative of x to the 4th. Everything ends up canceling out except this 4x cubed term. Could do it again with x to the 5th. And you're going to start to see a pattern. The derivative of x squared is 2x. The derivative of x cubed is 3x squared. The derivative of x to the 4th is 4x cubed. The derivative of x to the 5th is 5x to the 4th. Here's a pattern that we can use. We formalize it with what we call the power rule. So, if I want to take the derivative of a function x raised to an exponent, the old exponent comes down to the front to multiply. So see, this was x to the nth. The n becomes a multiplier in front, and I just knock the exponent down by 1. So here's an example on your paper. If I told you that f of x is x to the 5th, and I ask you to take the derivative, the old exponent is 5. So the 5 comes down to the front here to multiply. And the new exponent is going to be 1 less than the old exponent. So 1 less than 5 is 4. The derivative of x to the 5th is 5x to the 4th. So that's it's the easiest one to see where the rule comes from, because we could go through that expansion in the formal definition of the derivative that many times. But this rule works even if your exponent on x is negative, even if your exponent on x is a fraction, or even an irrational number. So look at this next example that's on your paper. We have g of x is 1 over x to the 4th. If I can rewrite that as x raised to an exponent, I can use that power rule again. So it's your job to remember, I can rewrite 1 over x to the 4th as x to the negative 4th. So once you realize that, I'm going to rewrite g of x is equal to x to the negative 4th. What's the exponent? It's negative 4, comes down to the front to multiply. My new exponent is 1 less than the old exponent. So negative 4 take away 1 makes negative 5. So negative 5 is my new exponent. If g of x is x to the negative 4th, g prime of x is negative 4 x to the negative 5th. Now watch this. So here I have h of x is the cube root of x squared. So if you remember the rules for rewriting radicals with exponents, or using fraction exponents to rewrite something as a radical expression, this number out here on the diving board, that's the index, that's going to be the denominator of the fraction. of the fraction exponent. And any exponent here on the x, that's going to be the numerator. So the cube root of x squared is the same as x to the 2/3. Once you rewrite this expression with a fraction exponent, I can use the power rule again. The old exponent is 2/3, so that's going to come to the front to multiply. My new exponent is going to be 1 less than the old exponent, so 2/3 take away 1 makes -1/3. And my final answer here, h prime of x, would be 2/3 x to the -1/3.